Hi everyone, so last week you did your first GCSE question of the week. I thought it would be a good idea to do one of these videos for each week that we do, so that not only if you missed it can you have a look at what you missed, but when you come to revise you can check through each one and make sure you're really secure. So we'll have a look at the foundation questions first, and question 1 asks us to write these numbers in order of size, start with the smallest number. So if we imagine a number line with 0 in the centre, our positive numbers would get bigger that way, and our negative numbers would get smaller this way. Okay, so we need to look for the negative numbers first, and the smallest negative number is the -5. That would be somewhere down here on my scale. And then the next largest negative number is -3, which would be maybe somewhere here. So notice that -5 is smaller than -3, even though the magnitude of the number, the size of the number itself, 5 is a bigger number than 3, but -5 is the smallest number. So we've got -5, then -3, then we're looking for our positive numbers. So up in order of size, I think we need the 4, then we need the 6, and we need the 9. Okay, so let's move on to number 2. And question number 2 says change 430 centimetres into metres. Well, the first thing we need to know here is that 100 centimetres is equal to 1 metre. So our conversion factor is 100, as there are 100 centimetres in a metre. But some candidates will struggle to know whether to times or divide. So let's have a think. We've got 430 centimetres. So this time I think we need to do a division. 430 divided by 100, and that's going to give us 4.3 metres. Let's just think that back through. If we've done it the right way, then our answer should make sense. So 430 centimetres, does that sound like 4.3 metres? Yeah, that sounds good to me, because each one of those metres is 100 centimetres. So the 4 metres would be 400, and then the 0.3 metres would be another 30. So we've gone the right way. Okay, if you're moving from centimetres to metres, the smaller unit to the bigger unit, you're going to need to divide. If you're moving from the bigger unit to the smaller unit, you'll go the other way in times. But if you just check your numbers back at the end, if you're not sure, just make sure it makes sense. Okay, number 3, what are we going to do? Change 0.3 into a fraction. Okay, well, a really common wrong answer here would be 1/3. Okay, the answer is definitely not 1/3. Okay, so if you made that mistake, let's have a think about why. Now, there might be some of you already that know straight away 0.3, I think that's 3/10, and you'd be absolutely right. So 3/10 is the correct answer. But if you're not sure, why is that? Well, you might know that 0.1 is 1/10. So if we know that 0.1 is a tenth, 0.3 is 3 times that, it's 3/10. If you're not sure about that either, maybe we could think of this. We could think about saying, okay, let's convert that to a fraction by saying, well, 0.3 is the decimal they're asking us about. Let's put that into a fraction form. So to do that, let's divide it by 1. Now don't get confused here, 0.3 divided by 1 is just 0.3. We haven't changed it at all, but we've put it into a fraction form. And what we can do now is we can say, well, it's a bit of a messy fraction because we've got 0.3 on the top. So let's make that to the equivalent fraction of something by timesing by 10. If I times by 10, my decimal point will jump to here. So we'll get 3 on the top, but we have to divide by, and then 1 times 10. We've got to times by 10 on the bottom as well. So that 1 times 10 is going to give me 10 on the bottom. It gives us our 3/10. So this is a handy trick. Okay, we can put the decimal on the top, put over 1, and then think about what we need to multiply on the numerator to get a whole number, an integer, and then do the same on the bottom. Okay, so if you weren't sure, that would be a good check. Okay, let's move on to number 4. Number 4, change 0.7 into a percentage. Okay, well, 0.7 as a percentage, some of you might know straight away. I think that's 70%. And if you know it straight away, you'd be absolutely right. 70% is the correct answer. But a common wrong answer would be 7%. And 7% is definitely not the right answer. So if you're not sure, let's just remind ourselves. If we want to go decimals into percentages, what do? We need to times by 100, multiply by 100. So the correct way to do these is 0.7. We're going to multiply that decimal by 100 to turn it into a percentage. and that's going to make our either digits move to the left, or if you want to think about the decimal point moving, our decimal point jump 2 places to the right. We're going to get jumpy, another jumpy to add a 0, will give us 70. Okay, so the right answer was 70%. Okay, let's move on to the higher question. Now it says higher, but this could also appear on the foundation paper. In fact, it did in the summer 2017. Okay, this question appeared on both. So let's have a look. What are we going to do? Work out 5.4 times 0.24. Well, to do that, there are really 3 steps. The first step I would suggest you do is convert both of those numbers just to integers. So we'll change that 5.4 to 54, and we'll change that 0.24 to 24. Okay, now in order to do that, we've multiplied the 5.4 by 10, and jumpy, we've multiplied the 0.24 by 100, but we can come back to that later. For now, just change them all to the simplest integer we can. So 54 times 24. Step number 2, we then need a way to do that calculation, and you need to have a way that you're confident of doing these calculations on a non-calculator paper. So I'll run through my method. My method's the old-fashioned method. I'm going to put 54, and in columns I'm going to put times 24. Okay, now I'm going to run through my rules. I'm going to do the 4 times the 4. They're both in the units column. I reckon 4 times 4 is 16, so I'll put a 6, but because my 1 belongs in the next column, I'll carry it down there. Then I'm going to do my 5 times the 4. I reckon that's 20, and I've got to add this 1 that we carried, that'll give me 21. Right, I'm now going to do the 2 times the 4 and the 2 times the 5, but remember the 2 is not really a 2, it's not in the units column. So what we're going to do now is we're going to put a 0 here. And I'm putting a 0 here because I'm looking at this 2, which is in the tens column. So I'll put my 0 ready. Now I'm going to do 2 times 4, which gives me 8. And I'm going to do 2 times 5, which gives me 10. Now I could carry my 1, but there's no extra calculation to do, so I can just put my 1 straight away in there. Then I've got to add these digits up. So I get 6 plus 0 is 6, 8 plus 1 is 9, 2 plus 0 is 2, and a 1 there. So I get 1,296. Okay, now that's the answer to 54 times 24. Let's just run through a grid method. If you prefer the grid method, you'd probably set up a 50 and a 4, and you'd probably set up a 20 and a 4. You set up your grid. You may not have left enough room. And you'd start working out the individual calculations. So we've got 20 times 50. Well, I'm thinking 2 times 5 is 10, and I have 2 extra zeros to add. So I make that 1,000. There's the 10, 2 times 5, and then I stick my 2 zeros on. 4 times 50, I reckon that's 200. 4 times 20, I think is 80. And 4 times 4, I think is 16. And if I add those up, 1,000, 200, 80, and 60. Made a right mess of that because I ran out of space. Let's do that down here. 1,000, 200, 80, and 16. And I'm going to get 6, 9, 2, 1. Woohoo! We get the same answer. So you need either one of those methods. Okay, our last step is both of those calculations gave us the answer to 54 times 24. Well, we wanted to work out 5.4 times 0.24. So the simplest way to do this is look back in our calculation, and in our calculation count the digits after the decimal place. So in 5.4 there's 1 digit after the decimal place, and in 0.24 there are 2 digits after the decimal place. So in total we're looking for 3 digits after the decimal place. So all I'm going to do now is take my 1, 2, 9, 6, and I'm going to put my decimal point in so I have that exact same 3 digits after the decimal place. So counting backwards, that will give me 1, 2, 3. If I put my point here, I get the correct answer of 1.296. Okay, now I said we go back to that thing I mentioned at the start. So why is that correct? Well, what we did when we converted the 5.4 to 54 is we'd multiplied by 10. And when we converted our 0.24 to 24, we'd multiplied by 100. So we've really multiplied by 10 and 100, that's like multiplying by 1,000, okay, in order to do our calculation. So we've kind of got to reverse that at the end. Our answer of 1,296 then needed dividing by 1,000 to get back to our 1.296. Okay, hope that helps. I'll give you some follow-up questions perhaps, and we'll think about some division ones maybe next time.